SURD refers to forms of irrational numbers expressed in square root form. For example, if you ask to evaluate this first one, where we have 2 root 63 minus 4 root 28 plus 5 root 112. What we do is that we try to see if there is a particular, the highest perfect square in the root, we bring it out. Perfect square, like if you have square root of 9, you know it will come out as 3. If you have square root of 36, come out as 6, and so on. So this 63 here, let me check. 63 divided by 3 will give me 21 divided by another 3. That means I can have 9 times 3, 9 times 7 as 63, 9 times 7. So this one will give us 2 into root 9 times 7. So the essence is this is perfect square. Square root of 9 is 3. So we'll later bring it out. Then minus 4 into 28. We can have 4 as perfect square there. That's 4 times 7 plus 5 into root 1. So I can see that this root, this sort here, the numbers in the root that will be left will be root 7. So let me say 112 divided by 7 to see what it gives. That is 16 times 7. And this becomes this 2 times square root of 9 is 3. It will come out of the root. Then root 7 does not have a perfect square, it's an irrational number. So we have minus 4. Square root of this 4 is 2. So it will multiply, it will come out as 2 and multiply the number, the coefficient outside. So we have root 7 plus this 5 times 16, 2. It's a perfect square, which is square root of 16 is 4. To multiply this 5 outside, and we have 7 inside. So when you simplify each of these, you have 6 root 7 minus 8 root 7 plus 27. Now, if you had 20 and 6 together, you get 26 root 7, because this thing is like if you have 6y plus 20y. So you say 26y. So the same thing, 6 root 7 plus 20 root 7 will give us 26 root 7. And if you subtract 8 root 7 from 26 root 7, just say 26 minus 8. So the answer will be 18 root 7. And this is a simplified result of this sort we have to evaluate here. We quickly go to the B part. To expand this, the first value inside the first parenthesis, we multiply the whole values inside the second parenthesis. Then the second value inside this first parenthesis, we multiply the whole values inside the second parenthesis. And we have root 3, we multiply root 3 plus root 2. Then minus 5 root 2 is going to multiply root 3 plus root 2. So from here, we can begin the multiplication. If you say root 3 times root 3, root 3 times root 3 will simply give us 3. Don't forget that if you say root 3 times root 3, we see it as root 3 times 3, which is root 9. And square root of 9 is 3. Or if you don't want to see it like that, from law of indices, whenever you see half root, root means power of 1 over 2. That means this one is power of 3 to the power of half times 3 to the power of half, which is 3 to the power of half plus half. And if you simplify this fraction, you get 3 to the power of 1. Half plus half is 1. So which will be also be 3. So anytime you multiply same sort together, for example, root 5 times root 5, you simply say 5. So for this one, root 3 times root 3 will come out as 3. Root 3 times root 2 come out as root, then inside 3 times 2, that is plus root 6. So we have opened this one. For the second one, negative 5 root 2 times root 3. That will be negative 5. Root 2 times root 3 is root 6. And negative 5 root 2 times root 2. That is negative 5. Then root 2 times root 2 is 2. And here we have 3 plus root 6 minus 5 root 6 minus 10. So we can collect like terms and simplify. We have 3 minus 10. That is negative 7. Then root 6 minus 5 root 6 is like you have y minus 5y. That will be minus 4y. So this one will be negative 4 root 6. So since minus 7 and minus 4 root 6 are not like terms, we stop there. We cannot simplify any further. And that is the B part. We quickly go to the C. In the C part, we have to rationalize. Uh, 3 over 4 root 3. The word rationalize means to make this fraction a rational number. Rational number in the sense that I told us that roots, if you have roots, most especially roots of prime numbers, root 3, root 2, root 5, root 7, they are all irrational numbers. And in any fraction, we are not allowed to leave irrational numbers in the denominator as denominator. So we need to remove this irrational number from being a denominator. So in order to do this, we say we want to make it a rational number by saying rationalize. So, and to do this, what do we say? We have 3 over 4 root 3. You know, if I multiply this thing by 1, does not change its value because 1 times anything is still that thing. But the one I want to introduce now will mean 4 root 3 over 4 root 3. Because 4 root 3 over 4 root 3 is 1 indirectly. So the essence is, I know that if root 3 is multiplying root 3, square root will cancel out and we don't have square root on the denominator. So that will help us satisfy the purpose for which we are rationalizing. So we say 3 times 4 root 3, that is 12 root 3 over 4 root 3 times 4 root 3. 4 times 4 is 16. And root 3 times root 3, that's root 9, which is 2. So from here, I can say 4 here, 3, 4 here, 4. 3 here, 1, 3 here, 1. So the result is 3, I mean, it's root 3 over 4. Or you simply say 1/4 of root 3. So we have this result. Don't forget that when I rationalize there, I multiply both numerator and denominator by 4 root 3. Since it is only root 3 we want to get rid of here, we can as well say 3 over 4 root 3. Our 1 may come in the form of simply root 3. And which will give us 3 root 3 when you multiply both numerator and denominator will be 4. Then root 3 times root 3, 4 root 3 times root 3, that is 3. So this will cancel out and we still have the same result. We move on to D. We move on to the D. In D, we are given two plus root 2 over 2 minus root 2 is expressed as x plus y root 2. What this implies is that when you simplify this, it will be in this form. And to simplify this, since we have roots as denominator, we want to remove that root. And to remove this root, we also rationalize. How do we rationalize this? The denominator here is a pair of terms. We have 2 minus root 2. It's not just root 2, or it's not just 2 root 2. So in this case, we call it, we introduce the conjugate of this, the conjugate of this. The conjugate of x minus y is x plus y, vice versa. So that is something that will make the result difference of 2 squared at the end of the day. So we say 2 plus root 2 over 2 minus root 2. We can multiply this one by 1. And that one will now mean conjugate of this, which is 2 plus root 2 over 2 plus root 2. So we have it as x plus y root 2 eventually. So let's simplify this. The numerator multiply, then this is perfect square now. We have 2 plus root 2 into 2 plus root 2 over 2 minus root 2 into 2 plus root 2. So which is x plus y 2. So if we expand this, 2 multiply 2, that is 4. 2 times root 2, that is 2 root 2. We have used this 2 to multiply everything here. Also use this root 2 to multiply. Root 2 times 2, that is 2 root 2. And root 2 times root 2, that is root 4, which is 2. Over this one is different or 2 squares. Simply say the first times first minus last times last. Or you open it. Middle term will still cancel out. So you have 2 times 2 here, that is 4. 2 times root 2 here, that is plus 2 root 2. Negative root 2 times 2, that is minus 2 root 2. You can see that 2 root 2 and minus 2 root 2 will cancel out. Minus root 2 times root 2, that is minus root 4, which is minus 2. So we still have it as x plus y root 2 here. So you can see this as cancelled out. On top, we now have 2 plus 4, that is 6. Root 2, 2 root 2 plus 2 root 2 is like 2x plus 2x, that is 4 root 2. Over, for this one, we have 4 minus 2 left, which is 2. So this one we know that numerator 2 is common there. We can factor out 2, which is 2 into 3 plus 2 root 2. You open by, you get the result by 2. So this will cancel out. We now have 3 plus 2 root 2 equals to x plus y root 2. If you compare this, we can see that this x is the whole number. It's not a surd. The term is not a surd. So, and that is this 3. The coefficient of root 2 here is y, and the coefficient of root 2 here is 2. That means if you compare, we can easily say that our x equals to 3 and our y equals to 2 comparatively. So we'll quickly go to the last one, which is E. In E, we asked to solve is an equation. We are given 4 root 18 plus 3 root 50 plus k root 162 equals to square root of 242. I told us how we simplify SURD the other time. Just look for the higher perfect square that is a product of this, or is a factor of this 18. Here is 9 times 2. So 9 times 2, that means we have 4. That 9 will come out as 3. Square root of 9 is 3. So we have 2 left there. Plus 3. The highest perfect square we can have is 25. 25 times 2 is 50. So that 25 will come out as 5. Square root of 25 is 5. And the root 2 will still be inside. Plus k, 62. 162. The highest we can see there is, if you divide 162 by 2, you will see that it's 81. 81 times 2 is 162. And that 81 is a perfect square. So it will come out, 81 will come out as square root of 81 is 9. And root 2 will still be there. Equals to 242. 242 divided by 2 gives me 121. That means 242 is 121 times 2. And 121, square root of 121 is 11. Then that 2 will be there. So let's resimplify this. We have 4 times 3 is 12 root 2 plus 15 root 2 plus 9k root 2 equals to 11. From here, let us rearrange terms. And we have 12 root 2. Here we have root 2. 12 root 2 plus 15 root 2. Bring 11 root 2 inwards. So we have 11 root 2 and transfer 9k root 2 to the right. So that becomes negative 9k root 2. So if we simplify this correctly, we have 12 minus 11, that is 1, plus 15, that is 16. 16 root 2. Just see it as if you have 12x plus 15x minus 11x. It will give you 16x. So equals to, we have 9 minus 9k root 2. Since this is an equation, we are solving it for k. That means anything around k is what we're going to remove. And what we are removing here is negative 9 and root 2. We see both of them as coefficient. We divide both sides by minus 9 root 2. So we have from there, we have 16 root 2 divided by minus 9 root 2 equals to minus 9k root 2 divided by minus 9 root 2. And at this stage, we can see that negative 9 will cancel negative 9, root 2 will cancel root 2. So here too, root 2 will cancel root 2. And finally, we have our answer. We have k left, which is k equals to negative 16 over 9. Because positive divided by negative is negative. Then we have 16 over 9. So this is the value of k in the equation involving SURD. Do subscribe to this channel for more relevant videos. Thank you.